रोहित जी।
यस मैम।
डॉक्टर अंकुर शर्मा सर को को होस्ट बनाइए, उन्होंने ज्वाइन किया है। रेवांगिनी जी को भी बनाइए, डॉक्टर रेवांगिनी जी को भी बनाइए को होस्ट। Dr. Shivai will be joining us shortly in 5 minutes. Till then, just stay tuned. रोहित जी, सईदा नहल को भी को होस्ट बनाइए।
रोहित जी, डॉक्टर साहब ने ज्वाइन कर लिया है, आप को होस्ट बनाइए उनको।
यस सर।
हमारे जो ऑनरेबल स्पीकर हैं आज के, उन्होंने ज्वाइन कर लिया है, को होस्ट बनाइए।
शिवा सर, किस नाम से ज्वाइन किया सर ने?
डॉक्टर
शिवाय
शिवा।
सर, SHIVAY, आप शिवाय करके सर्च करिए, आ जाएगा SHIVAY, यशवीर शिवाय।
यस यस सर, डन सर।
नमस्कार सर, जय श्री राम।
हाँ, नमस्कार जी, नमस्कार नमस्कार। गुड इवनिंग टू
गुड
एवरीबॉडी।
इवनिंग सर। नमस्ते सर, गुड इवनिंग।
गुड इवनिंग, नमस्कार।
सर, सेशन स्टार्ट करें सर?
आप देख लीजिए जैसा चाहें।
जी सर। रोहित जी प्लीज सर की हेल्प करिए, सर प्रेजेंटेशन शेयर करेंगे।
यस मैम, आई थिंक सर ने शेयर कर दिया। यस यस सर, योर स्क्रीन इज देयर सर।
स्क्रीन इज देयर।
यस सर।
सर एक बार प्लीज PPT मोड पे कर
पीपीटी
लीजिए सर।
इज इट नाउ?
डन।
डन सर।
डन सर, डन डन।
ओके।
डॉक्टर Evanggini,
Yes, ma'am.
please start the session.
Okay, ma'am. Good evening to one and all present here. I am Dr. Evangini Rancha, Director HR at AgriMeet Foundation, Bharat. It is my immense privilege and profound honor to extend a warm and heartfelt welcome to our esteemed eminent speaker, Dr. Yashbir Singh Shivai, a globally acclaimed scientist, distinguished academician, visionary researcher, exceptional teacher, and an inspiring mentor in the field of agricultural sciences. Sir earned his PhD from J.B. Pant University of Agriculture and Technology and further enriched his academic excellence through postdoctoral research in China. He has also served as visiting scientist and visiting specialist at reputed universities in Norway, reflecting his remarkable international scientific exposure and contribution. With extraordinary dedication and commitment, Sir served ICR, Indian Agriculture Research Institute, in various prestigious capacities, including scientist, senior scientist, principal scientist, and professor, making invaluable contributions to agricultural education, research, and policy development in India. Today, as Assistant Director Research, Journal at Indian Council of Agriculture Research, he continues to contribute and to guide and shape the future of Indian agriculture through his visionary leadership and scientific excellence. Sir's phenomenal academic and research contributions are truly inspiring. He has authored more than 350 research papers, 89 review papers, several books, manuals, technical reports, and over 250 popular articles in both English and Hindi. His outstanding scientific work has received more than 14,500 citations with an impressive H index of 62, which reflects the global impact and relevance of his research contributions. His areas of specialization includes soil fertility management, crop nutrition, rice wheat agronomy, ecological agriculture, and organic farming system. Though his pioneering research and tireless efforts, Sir has significantly contributed towards sustainable agriculture and nutrient management practices for the betterment of farming communities and agricultural ecosystem. Sir has been honored with numerous prestigious national and international awards, including Bharat Ratna Dr. C. Subramaniam Award for Outstanding Teacher, ICR IARI Best Teacher Award, FAI Award for Excellence in Plant Nutrition, International Zinc Association, Fertilizer Association of India Award, ISA Gold Medal, along with distinguished fellowships from renowned scientific societies such as NAS, ISA, ISPP, and many others. These accolades stand as a testimony to his unparalleled contribution to agricultural science, teaching, and research. Today, under the prestigious Krishi Navyug 3-month International Agri Training Cum Internship Program, we are truly fortunate and deeply honored to have such a legendary scientist and visionary personality among us. Sir, your gracious presence itself is the greatest source of inspiration and motivation for all the young researchers and agricultural professions gathered here today. So once again, on the behalf of Agriculture Valley Research Foundation, AgriMeet Foundation, and entire organizing team, I extend our sincere gratitude and warmest welcome you to serve. Now, without taking much time, I request and invite Dr. Shivai sir to kindly begin today's session. Thank you, and sir, the platform is all yours.
Thank you very much, Rivangani, for introducing so elaborately. I don't think I deserve so much of introduction, long introduction. And at the outset, let me thank to the organizers for inviting me. Am I audible?
Yes, sir. Yes,
Okay.
sir.
Perfectly audible and visible, sir.
Okay, thank you very much. So, as you know that today I have been invited to speak about that specific, the topic zinc agronomic biofortification for food and nutrition security. Why do we do the research? We do the research considering the practical applicability at the farmer's field or to overcome the food nutritional, that problems pertaining nationally or globally. So when I started my career, I worked on the value-added fertilizers like neem cake coated urea, neem oil coated urea, gypsum coated urea, sulfur coated urea, boron coated urea. Fortunately, neem oil coated urea is in the market, 100% neem oil coated urea now is being sold to the farmers. So when in 1992, when I joined IARI, and then I was asked to work under the supervision of Professor Rajendra Prasad. Rajendra Prasad is one of the illustrious agronomists of our country, and he has developed this neem oil coated urea technology. But I was part of the technology, and then I wish that another technology, zinc coated urea, should be made available to the farmers. Of course, sulfur coated urea is already there now, and like that urea gold, it is known as urea gold. That technology was developed and perfected in IARI, and then now that some of the companies they are making and selling in the market to the farmers. So as you know, this zinc is really important for our food and nutritional security. And considering that zinc as nutritional security and food security, we consider zinc as an essential element for the plant growth and as well as the human health and cattle health, and also in the food chain, right from the soil to the plant to the animal and human health. So in continuum, zinc is really important, and in our soil, zinc almost 50% is deficient. But you know that there are 10 food rich where that zinc is found sufficient quantity, like oyster, mushroom, beans, chickens, nuts, cashew nut or wheat bran, then crab, and then that there are some other product like beef and then pumpkin seeds. But other than that, that if we have a diversity in the diet, then we can also get that zinc in sufficient quantity. So what is the need? You know that important consideration for the zinc nutrition or zinc, you know that working on the zinc as a, you know that one of the intervention for increasing the production and productivity and also nutritional security. Considering the Indian scenario, in the Indian scenario, zinc is very much deficient and prevalent in that different strata of the, you know, that communities nationally, and villages are suffering more than urban area. Preschool going children, 17%, they are having low zinc intake and they are having the zinc deficiency, and the school children are almost 16%. Adults and specifically productive population, they are 31% having a problem of zinc deficiency. And there is some data like 2 billion population globally, they are suffering from the zinc deficiency out of 8 billion people, or 7.5 or 7.8 billion people. And 1.6 billion, you know that children, they are, you know that having a problem of zinc deficiency. Women are zinc starved. Annually, 4.5 lakh children are die because of the zinc deficiency. So it is really important, and it is having several repercussions of the zinc deficiency, like especially, you know, that kids, they are suffering from pneumonia, diarrhea, morbidity, stunted growth, malaria, dengue, and low intellectual development and wasting. So all these problems are associated. So Copenhagen's consensus 2008, they have said that zinc and vitamin A, it is most cost-effective solution to the malnutrition. And United Nations 2012 report say that zinc is a life-saving commodity. And several, you know, that activities have been taken regarding the zinc, save the Kid Foundation 2024, International Zinc Association. All these, they are concerned and taking some of the activities. This is one, you know, that published news I have taken from the Times of India in 17 December 2025, and then it says that zinc is involved in the immunity boost-up, so it can avoid that, you know, that infectious diseases, specifically in the winter season when mostly people suffer from viral and other problems. And you know that 50% of the common colds are caused by some kind of viruses, and they have found scientists have found some link between the zinc ability and then virus infection in the human body. So this is really important for the human body. And then how much zinc is required, you know, that daily for the human being. So 8 milligram women and 11 milligram for men, it is sufficient. And up to 50 milligram toxicity is not found, but if you take more, then there is some, you know, that problem with the zinc toxicity. And these are the some food rich in the zinc, like shellfish, like oyster, crabs, shrimps, and lobster, red meat, poultry, meat, yogurt, cheese, pumpkin seed, which I have already discussed. But again, and beans, specifically rajma, and then some, you know, that pulses, lentil, chickpea, all these are important. Oats and brown rice, not the white rice. Brown rice, where that micronutrient intact in that, you know, that aluminum layer, and then they are more available. Then some of that vegetables like spinach, peas, mushroom, all these are very important source of the zinc in our food chain. This, you know, that zinc deficiency in humans, first time zinc deficiency was reported in plants, specifically in rice. If you remember, most of maybe agriculture graduate student, that Dr. Y.L. Nene first time discovered zinc deficiency as a Khara disease in rice at Pantnagar. But in humans also, you know, that Dr. A.S. Prasad, Anand Singh Prasad, he was from Bihar. He was deported in that Iran and, you know, Egypt in World Health, WHO, World Health Organization, one, you know, that project. in these two countries. And the first time he reported that zinc deficiency could be accounted for human growth retardation. And this was the first report, which was reported, that in some good journal. Good journal means he has published in American Journal of Medicine and in 1961. And this was the landmark journal because that again it was, that reproduced same article in that 1990 Journal of Laboratory and Clinical Medicine. So that means that was that it is not only that zinc deficiency identified in rice in our country first time, which was having a major concern as a Kara disease, but other crops also, but human beings also. So he correlated that, that retardant in the growth. If you see this picture, almost age group like 21 to 18, but their growth is very short. That means not more than 5 feet, less than 5 feet. So he was the first man to identify and then correlate that zinc is involved in the, that stunted growth. And these are the characteristics or symptoms zinc deficiency in humans, redness or reddening on different parts. So that means zinc is really important for our food. So what is that zinc is having multifaceted uses globally, and it is involved in different, that life activities, we can say, like green building, renewable energy, infrastructure, life-saving means like tablets and other things, then transport, then energy storage, manufacturing energy, and nutrition security, of course, important. But here I would like to, that apprise you that zinc market globally is almost 40 billion US dollar. But only, that a small quantity, even less than 2% is used in miscellaneous. That means fertilizer and then other activities. Most of the zinc is used either galvanizing 60% or die-cast alloy. So that means only small quantity is being used as a fertilizer. So countries at the risk of the zinc, low zinc uptake and soil zinc deficiency. If you see this picture, this is from the International Zinc Nutrition Consultative Group and also International Zinc Association. They have published this picture where it indicates that our country, that is having a serious problem of inadequate zinc uptake, almost more than 25%, stunted growth more than 25%, and this is a serious concern. Another figure or picture I have taken from Wessels and his associate 2014, they have also pointed out that our country or India is suffering almost 40 to 50% population in the zinc deficiency. They are zinc starved, and they are having a, that problem. And this figure I have made my own with the data available from that All India Coordinated Research Project on the micronutrient and heavy metals, Dr. Shukla and his associate 2021. So in this picture here, I would like to emphasize that zinc deficiency is highest in the Tamil Nadu, 63.3%, and then followed by Madhya Pradesh and then Rajasthan. Other states are also suffering. You can say that almost few states, they are having sufficient, only in northeastern state, but almost all states, they are having the zinc deficiency in their soils. And One Health now is considered. So One Health starts from the soil, and soil to that plant to animal and human health. And that is very important to understand why the zinc deficiency is there in our population. Then there are other reasons for that cereals and human nutrition, why our population, they are suffering from the zinc deficiency. Cereals are the major source of energy for rural people. Rice and wheat, most important food in our food chain, even that public distribution system, these are the two important grains are supplied for 66% population after the introduction of the food security bill in 2000 13 in the parliament by UPA government. So that means rice and wheat, they are important. But what about the, that zinc content in the polished diet? It is only 8 to 14 milligram per kg. Wheat, it varies from 15 to 45 milligram, and in maize, even less than wheat, zinc is found. And for us, that storage is also equally important for our food chain, because we are having the largest bovine or cattle population in our country. So that means it's not only grain, but also storage is also equally important for us. And for better food nutrition of zinc, cereal grains should contain at least 40 to 60 milligram zinc per kg. But the current situation is very low. It range from 10 to 30 milligram. And that is why that approach will not work in our country, because we are having a very diversity in agroclimatic conditions. Humans' preference to eat rice, wheat, or maybe millets or other crops. So considering all these scenario, we need to work from different aspects. This I have taken, that cattle population census is going on, but I have taken some data that it indicates in 2015, it is estimated that 300 to 307 million cattle heads are there in our country. Around 193 million cows and 110 million buffaloes. So altogether, it suggests that data that largest cattle population is there in our country. We are not number one in population, human population, but also cattle population also. So our problem to feed with this, that only very less, I can say that 2.5% land resources and 5% water resources. And also we are feeding 17 to 18% human population and 15 to 7 cattle population. So our different approaches will work. So cereal-based consumption is really a concern for the low zinc concentration uptake in the rural areas where the diversity of the food is not there. There is also, sometimes we suffer from the micronutrient deficiency, but we don't understand whether we are suffering. Sometimes we feel lethargic, we feel unproductive, we feel, that sleepy. So that means there is some deficiency of the micronutrient, which are very important for our, that metabolic activities and making alert and productive. So hidden hunger, this is not seen, but it is there. So that means why it is there. High productive cereals, that mostly now we are growing. We have now area under specifically pulses and micronutrient rich food is less. And cereal price is decreased. And that is why consumption, that is more. So this is one reason that hidden hunger is there, because of that malnutrition of the micronutrient, specifically zinc, iron, and provitamin A or vitamin A. These are the important considerations. Sorry. So what strategies we can take care so that we can overcome that hidden hunger from the, that human population? Dietary diversity, it is very important. If we can have that diversity in the diet, that means we are eating meat, eggs, fish, or pulses, oilseed, and we are taking also vegetables and fruits and along with the cereal, then there is no problem. We need not to take a supplementation. Even if we eat a chapati of pearl millet every day, there will not be micronutrient deficiency, because pearl millet is a rich source of the iron and zinc and other, that micronutrient. Supplementation, of course, there is some program of supplementation, iron tablet supplementation, or that iodized salt. So these are the some strategies. And in some state, I understand in Haryana, some supplementation program is there for the zinc also. Then if you see this tablet, it is luxury, which contains coenzyme Q10, lycopene, omega-3 fatty acids, selenium, mixed carotene, calcium carbonate, ascorbate, wheat germ oil, vitamin, and zinc. You see this zinc is there. So its cost, one tablet costs around you know that almost I can say it is 70, 80 rupees. So everybody cannot afford this tablet. So supplementation, of course, it is there, but it is a costly affair. Everybody cannot afford. Then fortification. Fortification is a physical mixture or physically mixing of the desired micronutrient, iron or zinc or maybe folic acid or any other, that minerals desired. And then fourth one is specifically is biofortification. And in market, we get that, that zinc fortified rice or iron fortified rice. So fortification program also government of India has launched in some, the districts, targeted districts. But I think now there is some problem in fortification, specifically iron fortified rice. Then biofortification, it is sustainable because it involves that increase of the micronutrient, desired micronutrient in the plant system itself and the assimilation. And then ultimately it, that go in the right direction and also reach to the consumers. So what are the different other approaches we can take care for the zinc deficiency? There are different approaches I would not like to discuss because today I am going to speak only about agronomic approaches of biofortification, but genetic approach is also very important, specifically conventional breeding or transgenic approaches to increase the zinc concentration or decrease the phytic acid. Because zinc content and phytic acid, they are having a negative correlation. If we can decrease the phytic acid, then zinc assimilation is more. Zinc content can be increased and its absorption can be increased. Agronomic biofortification is through like fertilizer application, whether it is soil foliar application or bionucleants, specifically biofertilizers, or crop residue, green manuring, etc., or dual-purpose summer green manuring, intercropping, mixed cropping. So these are the comes under the umbrella of the agronomic approaches, which today I am going to speak. So in general, what do you understand by that biofortification? It is the process of increasing the density of vitamins, minerals in the crop through plant breeding and agronomic approaches, so that that biofortified crops, when it is being provided to the consumers regularly, generally it that generate the measurable improvement in the vitamin and mineral nutritional status. So that is known as biofortification. That means in the plant system itself, we are going to increase the content. And so far, ICR has released more than 171 biofortified varieties in 16 crops up to 2025. I am not aware this year whether they have released some varieties of biofortified, but this was the last year report which I have written in my previous presentation. One of the papers we published, Prasad in the associate, I was also co-author in that, in Advances in Agronomy 2014, biofortification, where we have again, that categorized the conventional approach, including agronomic approach, breeding approach, and biotechnological approach, specifically molecular markers and genetic engineering. That now gene editing and other approaches are also there. So we can explore these possibilities also, which is a sustainable and long term. But short term, agronomic biofortification is very important because agronomic biofortification, that within that released varieties, we want to increase the concentration. This is the most important thing, because any variety, suppose breeders release and the consumer don't like, specifically you see this golden rice. Billions of US dollars were spent on the golden rice, but nobody is eating because that consumer's preference is very important. Some people like, that basmati rice, some people like the starchy rice. So considering that consumers, that consumers' preference, we want to increase the desired micronutrient content through agronomical approach. And there is no sacrifice on the yield penalty, because for breeding, there may be a yield penalty, but in agronomic biofortification, there is no yield penalty. Rather, also yield is also enhanced along with the zinc concentration. So what are those approaches? Like adequate fertilization, method of fertilizer application, method of application, whether soil application, foliar application, or coating, or maybe bio-inoculant. Time of application is very important, whether it's the time of sowing or maximum tilling or foliar, maybe at that flowering stage or grain filling stage. Then integrated application of the nutrient is involving FIM, farmyard manure, vermicompost, etc. is very important. Crop rotation. Crop rotation means when we are following, that rice wheat. So if we introduce that mung bean in the rice wheat cropping system, it has additive effect on the micronutrient mineralization. Or we also include in rice wheat cropping system or maize wheat cropping system, Susbania or Crotalaria gentiana, that is Sanamp as a green manuring. So it increase that, that micronutrient ability. Then intercropping, specifically wheat and chickpea. This is one of the best example, published a lot of paper from the China, but in our country, people are not publishing on this aspect. Division of Agronomy, Dr. Subhash Babu, now he has taken a lead. He is publishing good articles on intercropping. How intercropping, root rhizosphere engineering, they are helping by, that root regulates to solubilize the specifically insoluble nutrient and thereby uptake by both the crop. So this is very important to understand. And by this approach, we go either foliar feeding or we go for soil application, and then it comes under the plant system translocation and then retranslocation from source to the grain filling period. So for agronomic biofortification, either we can go fertilizer or microbial, that acquisition or mobilization of the micronutrient, which we have done a lot of work in collaboration with the microbiology division, and we got a very good, that response. So zinc agronomic biofortification of food grains, specifically, that for only for zinc. So 4R is very important. That means right source, right rate, right time, right method. What are the different sources of the zinc? There are different sources of zinc like zinc sulfate, zinc oxide, chelated zinc, organic manure, green manuring, zincated urea, which we have developed and then also used and seen its efficacy. And also now nano zinc oxide or nano materials are also there. Nano zinc oxide or nano, the different formulations are there along with these conventional fertilizers. Rate, whether we go for single crop or cropping system, that is also very important. And then time, whether seed priming at the sowing or transplanting or grain filling stage, this is very important. And method, whether we go for soil application, foliar or conditioning, or maybe that root duping. So these are the very important aspects. So one method may not be applicable to another crop. We have to identify and work, that separately. This is, that situation of the right source of zinc application. You see, this is the zinc sulfate heptahydrate. A farmer, small farmer, buy a 10 kg zinc sulfate or 5 kg zinc sulfate, he or she is not able to use whole quantity. Rest of the quantity he keep for, that next season. So during the next season, there is a hydration and it makes the lumps. And a farmer cannot use, that fribly or, that as per that fine granules which is available in the fresh bag. So this is the scenario. So we have done some conditioning of this zinc sulfate heptahydrate with the zinc oxide 2 gram and neem oil 4 gram and then 94 gram zinc sulfate heptahydrate. And then we found this product was very stable, no hydration, even after 6 months or 8 months, it was very friable. And we have also, in our laboratory, we have also developed a new urea. If you see, this is a PRID urea or common urea, and this is a 0.5% zincated urea, zinc enriched urea, and then 1% zincated urea. And this is zinc EDT and this is zinc oxide. So these are the different sources which I have tried to show you that how they looks and then how they work. Now coming to the, that sub impact on our developed zincated urea or zinc enriched urea on the zinc concentration, and in that the different crops where we have used different crops, and first experiment we conducted, you know that taking the 0.5% zinc to 1% zinc enriched urea through zinc oxide and zinc sulfate. And we found that very good response to in terms of that, you know that zinc content increase in the grain as well as extra 30% increase in the grain and 28 to 28.5% increase in the extra. And you know that recovery efficiency was as high as 17%, whereas the soil application, if we go, any micronutrient, it is not more than 2%, it is always less than 2%. So that means zinc enriched urea can increase the zinc concentration in the, you know, that economic part of the plant, whether it's grain or straw, and it also increase that zinc recovery efficiency and also further increase the productivity. And productivity enhancement from 3.95 ton to 4.68 ton increase. So we have shown it graphically, and this paper was published in Nutrient Cycling Agroecosystem in 2008. And in 2008, we have published 3 articles in Nutrient Cycling and Agroecosystem on same aspect. And after that, we were not able to post article in this Nutrient Cycling Ecosystem as a senior author, but co-authors we have published also other articles. Then another study we carried out considering the lead, taking the lead of 0.5 to 1% zinc and urea. Further, we have gone 2% to 3.5% zinc and urea in the cropping system mode, rice and wheat. Earlier study we conducted only in the rice. So we also got a very good response to the system base, where you know that almost 61% increase in the zinc concentration in the grain with 3.5% zinc enriched urea and extra 61%. Zinc recovery efficiency was with the, you know that high with that 2% zinc enriched urea, and as we increase the zinc concentration in the urea, there was decrease in the zinc recovery. But yield also increased and all grain yield and extra yield also. And that paper was again published in the Nutrient Cycling Ecosystem. That this was the residual effect which we have seen in the wheat crop. Wheat crop also benefited 30% or 31%, you know that zinc increase in the wheat grain and 48.5% increase in the wheat straw. And recovery efficiency was high with the 2% zinc and urea. Grain yield for style also enhanced significantly, ranging from 15% to 19%. And here I would like to mention that zinc concentration was found in more in the case of wheat grain. But if you see this previous slide, so previous slide, in this case, zinc concentration was higher in the straw, not in the grain. So in rice, there is a, you know, that problem of the zinc translocation, but in wheat it is not there. And when we try to, you know that I try to show this data to my professor, Professor Rajendra Prasad, he was not convinced, and he said that both the crops are having that similar, you know, that crop morphology and root morphology, and they should have the same behavior for zinc assimilation. They should have more concentration in the, you know, that straw in wheat, but it was reversed. And it took 6 months to convince her. And then when one paper published from the PAU Ludhiana in Indian Journal of Fertilizers, then he shown me that Dr. Sive, you are right, let us get it published, our data. Then we have done another study where we have taken zinc enriched urea in wheat only. And we found that there was significant increase in the zinc concentration, 24% increase in the grain, and again 24% in the straw. But here again zinc concentration was more in the grain, and that paper we have published in again Nutrient Cycling Ecosystem. So 3 papers we have published on zinc enrichment in the urea and its efficacy evaluation as a zinc enrichment in the grain and straw of rice and wheat, both crops, and also recovery efficiency and also increase in the productivity. This is the work of one of my PhD students. Now he is Dr. Vijay Punia, my colleague working as a senior scientist in the Division of Agronomy. Recently, I have shifted here only this month on 5th. Before that, I was located in Division of Agronomy as a professor. So he took the different approaches for see the zinc zinc enrichment in the grain in the basmati rice. 2% zinc and urea through zinc sulfate heptide, not heptadite, but monohydrate. He has taken then 2% zinc and urea through zinc oxide and 5 kg zinc per hectare zinc sulfate monohydrate and 5 kg zinc per hectare zinc oxide and zinc oxide slurry and foliar feeding 0.5% as a zinc sulfate monohydrate. And he found that very good response to the 2% zinc and urea through zinc sulfate monohydrate, where he reported 13.6% yield productivity, 28.3% enhancement in the grain zinc concentration, and 17.7% in extra concentration. Another student now, again, he is my colleague, Dr. Shankar Lal Jat. He is working in Indian Institute of Maize Research. He was my PhD student. He also shown that it's not only basmati rice, but also aromatic hybrid rice, PRS10, first hybrid rice aromatic was developed by AARI, and he shown that at least 6 milligram zinc enhancement can be done if we go for 2% zinc and urea with zinc sulfate heptahydrate. And other approaches also increase as compared to the control in the zinc enrichment. Another study we have done and published in Proceeding of the National Academy of Sciences, India, where we have taken, that two sources of the zinc, like zinc sulfate heptahydrate and zinc EDTA. So, and we have taken the soil application, also foliar application 0.5%, 0.5%, 0.2%, 0.2%, 0.5%. We found that between these two sources, zinc EDTA was better when we applied at, that 0.5% at the flowering, distilling stage, rooting stage, grain filling stage, as compared to the other sources, other methods. And it was reported that 28.4% enhancement in the grain zinc concentration of basmati rice and 19.9% in the extra concentration of the zinc. Recently, one of my PhD student, Mr. Kirtiranjan Baral, who is now scientist in Indian Institute of Soil and Water Conservation Research Institute located in Odisha, Koraput Center, he has done, some characterization of different zinc sources used in his study, where he has done SAM means scanning electron microscope of bulk zinc oxide and nano zinc oxide, and SAM of urea, that is urea, and SAM of the 1% bulk zinc coated urea or zinc and its urea, and then SAM of the 0.1% nano zinc coated urea. And also, that other, methods we have approached. So it's not only that only we are applying and we are not correlating with the particle size and other things for better penetration in the plant system and their assimilation. So he reported that zinc fertilization, or for biofortification of the zinc rice, zinc in the basmati rice, where he reported that 1% bulk zinc oxide coated urea has better as compared to the other methods of zinc application. And similarly, in case of the grain yield and in case of the zinc concentration, 23% enhancement was there when we used that 1% bulk zinc coated urea for agronomic biofortification of zinc in basmati rice. That paper we have published in Frontiers in Sustainable Food Systems. And then similar study we also continued in the cropping system, that is wheat, rice wheat system. Again, that 23% increase was there because of that 1% bulk zinc coated urea in the wheat productivity, and also 22% increase in the zinc concentration in the wheat grain. and almost 48 milligram zinc per kg of grain was reported by this study. Then coming to that, you know that after sources, rate of application is very important for agronomic biofortification. So we did one study and published in Indian Journal of Agronomy, where we have taken that different levels of the zinc, and we estimated the zinc concentration in the chickpea grain and zinc concentration in the straw. And we have reported that 31% enhancement in the zinc concentration in the wheat grain because of the 7.5 kg zinc application as a soil application through zinc sulfate heptahydrate, and almost 39 to 40% zinc concentration enhancement in the chickpea straw. Then coming to the integrated use of the green manuring, dual-purpose summer legumes and bionucleate for zinc nutrition. It's not only fertilizer, but summer green manuring also plays a very important role. One of my students, now he is a senior scientist in Central Cotton Research Institute, Regional Station Sirsa, Dr. Amarpreet Singh, he did this effect of summer green manuring crop and zinc fertilizer sources on productivity and quality of aromatic rice and durum wheat cropping system. So we have taken Susbania, we have taken Sunais or Sunam, we have taken cowpea as a, you know, that summer green manuring, and then we have raised the rice, and then we have raised the, you know, that durum wheat. And what we have reported and published in Pedosphere is a very highly reputed journal, having a impact factor of 6, almost 12 NAS rating, where we have shown that Susbania aculeata productivity enhancement was there almost 13.9% in grain, 7% in straw, and also grain enhancement 33.8% in the rice grain and straw 12.6% because of only summer green manuring as compared to the fallow. And also we have taken different sources like zinc sulfate heptahydrate, 20%, 21% zinc content is there. Zinc sulfate monohydrate, 33% zinc. And then EDTA zinc. And we found EDTA zinc is better in enhancement of the productivity of the both the, you know, that grain and straw, and almost 70.5% enhancement in the grain zinc concentration because of EDTA zinc, and 19.8% in the straw. So here I would like to, you know, again emphasize, as compared to the durum wheat, as compared to the estimum wheat, the durum wheat contain less, you know, that zinc content in the grain, but high content in the straw, but whereas it is reverse in the estimum wheat. And then we have also, you know, that published another article in Biological Agriculture and Horticulture, where we have shown that the effect of residual summer green manuring and zinc fertilization on quality and zinc concentration of durum wheat under basmati rice durum wheat cropping system. And we found that very good response as compared to the summer fallow, only, you know, that 4 ton yield, but here 4.65 ton durum wheat, and also higher yield of the style zinc concentration, you know, that 35.62 in the fallow or summer fallow, and 42.8 per, you know, that milligram per kg of zinc was there in that grain, and also beta carotene and protein content much higher as compared to the summer fallow. And also EDTA or chelated zinc was better in increasing the yield productivity and enhancement of the zinc content in the grain straw, and also increase the beta carotene and also protein content as compared to the control and other sources. So it's not only, you know, that biofertilizers or maybe, you know, the fertilizers, but also if we use double summer green manuring. For example, we have taken here summer fallow, here mung bean and cowpea. In compared to the summer fallow, cowpea has recorded much higher zinc concentration in the aromatic hybrid rice, and also zinc concentration in the straw. That means we grow as a summer green manure, cowpea, mung bean, we take the, you know, that they have pods for vegetable or seed, and then seed from the mung bean, and after that we grow rice. So there is a yield enhancement as well as the zinc concentration. This is one of that, that classical work. If you see our, that my work, specifically citation, biofortification of wheat through the inoculation of, that rhizobacteria and cyanobacteria. It is one of the highly cited article where we have shown that we take absolute control NPK and 50% nitrogen, 100% P and K, 50% nitrogen and full P and K, and CW1 means it is a cyanobacteria strain, and PW means Providencia species. That means both are biofertilizer, and we have been able to get that response. 12% zinc concentration increase and 4.56% in the protein content, and yield as high as increase as that I can say 9%. If you see this figure, can you see? I'm pointing out. Can you identify who is that gentleman in 2010? Are you able to see it? Hello? Anybody? Hello?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Can you identify who is that gentleman where I'm indicating? I am me only.
Okay, sir.
I am only me. When we shown this experiment,
Ji.
I was just, doing the help to showing this experiment through that handful, that plow. So that means if you do really sincerely, you get response and publish, you become satisfied with your work. So
Yes.
another study we have taken where we have taken, the different approaches for agronomic biofortification in basmati rice, fallow, Susbania and cowpea, and we found that Susbania was better in the enhancement of the yield of basmati rice and also zinc content in the basmati rice, 24% as compared to the summer fallow. And we have published this article, Frontiers in Plant Science, again one of my PhD student work. So how much zinc can be added through, that Susbania, and then how much zinc can be added, that through Crotalaria gentiana, that is Sanai. Almost, that this much of quantity, 84.1 gram per hectare can be added through that, which we have estimated through recycling of this crop residue, and 90.9 gram through the Crotalaria gentiana, that is Sanai. And Dhacha can increase almost 18% yield enhancement in rice, 12% in wheat than fallow. And also, there was increase in the density of that zinc concentration in the grains and wheat. And similarly, we have also shown that in the durum wheat, and also this is in yield enhancement in rice, and this is in durum wheat, where that significant difference you can see in both rice and wheat as compared to the control means fallow, summer fallow. And there is also an enhancement in the grain zinc concentration in rice and wheat, both the crops, rice, wheat. So that means intervention of the summer green manuring can also help in accumulation of better zinc in both rice and wheat. Then time and method of zinc application. We did one study and published in Communication in Soil Science and Plant Analysis, where we have taken two sources of zinc sulfate heptahydrate, soil application, 1 foliar, 2 foliar, 3 foliar spray, a different vegetative flowering and grain filling, and with the EDTA soil application, then foliar 1, 2, 3 spray. And we found that if we go 3 foliar feeding with the EDTA zinc, that is vegetative flowering and grain filling, almost 52% increase in the zinc concentration in grain of chickpea, and 91% enhancement in the chickpea extra concentration. We have also estimated that, that recovery efficiency and agronomic efficiency, which is very important when we applied, and how much increase is there because of zinc application and how much recovery is there. So this specifically zinc DTA2 foliar spray vegetative and flowering resulted in highest agronomic efficiency, almost 450 kilogram increase per kg of zinc application, and also as high as recovery 15 to 16% crop recovery. And then we have also done another study on agronomic biofortification of improving the zinc nutritional quality of the oats. What is very important. Why? Because that those people are suffering from cholesterol and other things. Doctors are prescribing oat as in the that breakfast. So it is a good source, good fiber for that cholesterol people. So my mentor asked me to conduct one study where we have taken that different zinc treatment like soil application, sowing time, then seed coating onto seed of 100 kg. Only 2 kg zinc was applied. And among all these sources, whatever I have mentioned here, I found this was the best to increase the zinc concentration, 44% in the zinc concentration in the grain of that oat, agronomic efficiency 428 kilogram grain increase per kg of zinc applied, and also net return crop recovery efficiency 17%, and also 26% in enhancement in the grain yield of the oat. So that means we need a different approaches, different that methods of zinc agronomic biofortification for different crops. One approach will not work for all the crops. That paper we have published in Agriculture Research NAS Journal. Another study we have done in maize. Maize is a very difficult crop for the agronomic biofortification, but we have tried it and we have published that paper in Egyptian Journal of Biology. But unfortunately, this paper, now journal has stopped to publishing, but at that time it was having 1.5 impact factor, 7.5 NAS rating when we published this article. And we found that soil plus foliar application of zinc, 5 kg zinc as a soil, 1 kg as a foliar application, is able to enhance 22.3% zinc concentration in grain, 43.3% in the corn or stover. And also agronomic efficiency was higher with only foliar feeding. It is obvious, and recovery also efficiency. Then first time we have introduced one definition, effect of secondary or micronutrient deficiency on nitrogen recovery efficiency in different crops. Before that, nobody has reported this zinc-induced nitrogen recovery efficiency, for which we have introduced one calculation or formula, that is zinc-introduced nitrogen recovery efficiency in percentage, 100 within bracket nitrogen uptake in the zinc-treated plot minus zinc uptake in the control plot, where we have not applied zinc, divided by nitrogen applied. And we have been able to show that how that synergistic effect is there when we apply zinc. It also increase the nitrogen recovery efficiency because they are having a the synergistic effect. So almost when we applied 5 kg zinc as a soil application, 1 kg foliar feeding, it increased almost the 27.3% increase because of zinc application. So that means that is why we are that promoting and advocating to increase the zinc coated urea to the farmers, even if that they reduce after 45 kg to 40 kg as urea gold for 40 kg sulfur coated urea. That will be that very good source for the farmers to overcome the zinc deficiency. Some study we have done conditioning, which I have shown that zinc sulfate heptahydrate, it makes lumps, and if we go for conditioning with the zinc oxide and neem oil, it increase the that durability and storability, and then its application. Government of India Fertilizer Control Order, it should have 21% zinc concentration in the zinc sulfate heptahydrate and pH more than or equal to 4. However, zinc sulfate marketed as the following drawback like lump formation during storage, a lack of free flowing, the presence of the free acidity that injures seedlings. So we considered, and then we tried to condition, and then also that to evaluate its efficacy, considering, and then we published in Current Science that paper in 2011. And we found a very good response in, that conditioning of the zinc sulfate after hydrate and neem oil on growth and productivity and biofortification of zinc and zinc uptake, where we have shown that 2.5 kg zinc sulfate, zinc oxide, neem oil condition as a foliar application or soil plus foliar application, 2.5 kg zinc or 2 spray. Both are equally important to increase the zinc concentration in grain as well as in straw. And then we have also estimated the crop recovery efficiency and agronomic efficiency. Again, soil plus foliar application or only foliar application has increased, that tremendously zinc crop recovery efficiency and also agronomic efficiency as high as we can say around 270 kg per kg of zinc applied. And another approach we have done crop establishment and nutrient management for rice wheat cropping system for enhancement. Then puddled rice and aerobic rice. This paper we have published in Journal of Plant Nutrition, and we found that puddled rice is better in that assimilation of the zinc in the milled rice, bran and hull. It is not only important, that milled rice contain very less zinc content as compared to the bran. So bran is the most, that most of the micronutrient located in the alluvial layer during processing whitening period. When we go for whitening of the rice, it goes to the bran, and it contains a lot of that zinc and iron also. And also when we added the nutrient along with the RDF, there is a significant increase in the zinc content in the specifically milled rice, bran, and also hull. So that means it's not only fertilizer but also method of cultivation influence the zinc assimilation in the economic part of the plant. Variety also, that has a, that variation. And again, we published that paper, Journal of Plant Nutrition, where we have shown interaction effect of nitrogen, phosphorus, zinc fertilization. And specifically between these two varieties, if you see this Pusa rice hybrid 10, it contains more zinc concentration and also more grain yield as compared to the Pusa Basmati 1121. But this is a premium variety in terms of the long grain and making use of it in the pulao or biryani, etc. And again, that along with the NPK or we have applied zinc, that again it has increased the zinc concentration, also grain yield per plant. It's not per, per hectare, but it is per plant in gram per plant yield. Then some genetic differences we have estimated for the zinc response. For example, in chickpea, we have estimated some varieties. We have taken Kavli and Desi. We found that Desi varieties, they contain more zinc as compared to the Kavli, both in grain and in straw. So that means breeders can also focus for biofortification in Desi varieties in compared to the, that Kavli variety. We have also done some study and published in Journal of Plant Nutrition. We have taken different varieties like PB1, Pusa Basmati 1, Pusa Sugan 2, Pusa Sugan 3, Pusa Sugan 4, Pusa Sugan 5. And we found that, that zinc increase, that kilogram grain increase per kg of zinc was high in Pusa Sugan 2. That means response of zinc application was more in this, but zinc concentration in rough rice was higher in the Pusa Sugan 3. So that means agronomists and breeders can work hand in hand for the agronomic biofortification program and as a crop improvement. It's not only breeders can contribute, but also this is one study which we have published in Indian Journal of Plant Physiology. Now Plant Physiology report, same journal is being published in Plant Physiology reports. So we have shown that white rice contain hardly 20%, 30% or 29%, but most of the, that zinc concentration either remain in the hull or bran, or that means, that it is not edible. It goes, to the other purposes. So if you eat brown rice instead of white rice kernel, then you can consume more, zinc as compared to the white rice kernel. These are some other studies. I think how much time I can take, can you tell me? Because 1 hour is already there. So accordingly, I will try to bind up my lecture. Can you tell me, Dr. Pragati? Hello?
Yes, sir.
How much time you can, huh?
So you can complete your presentation as per your like how much time do you have? Otherwise, students will be there for 15 to 20 minutes of discussion.
Okay, so I think I should try to now wind up because 15 to 20 minutes I will have discussion anyway. So again, you know that in another study, we have taken a different varieties, village varieties. One of my PhD student now is a senior scientist in VPK Salmoda, and he has done, taking different genotypes for the soil application, foliar application, and two sources, zinc sulfate heptidate and EDTA, and we got a very good response to yield improvement in the productivity and the variation in the gender. We have published this article in that very high impact factor, the crop. The crop journal is having almost, that 7 impact factor, and it is published by Chinese Academy of Agriculture Sciences. And we have also done estimation for zinc concentration or uptake by different, parts of the rice like straw, hull, bran, and white rice kernel. So white rice contain very less as compared to, that other, concentration in straw, hull, or bran. And zinc uptake, that also almost 20 to 30% in straw and white rice kernel because of that total yield. But in percentage wise, it is less. Then we have also done some study on release varieties in the public domain, like for example, ID 2967, it is a 2967 very high yielding variety still in that grown in the 6 to 8 million hectare area in India, and other PBW 343 SD 2894 we have taken, and we found a very good response to the zinc application in almost all, and soil application plus foliar feeding was better. Then zinc concentration and improvement in the wheat we have shown in grain, extra, and spike also. Generally, people don't estimate in the spike, but we have estimated a spike also extra. And we have also zinc uptake improved because of that, that zinc application. This much variation response was there because of zinc application. This paper we have published in Archive of Agronomy Soil Science again, very high impact factor. Then we have also done some study recently, biofortified, non-biofortified varieties. One of my PhD student now scientist in Indian Institute of Millet Research, regional station in Badmer district, Rajasthan. And he has shown that non-biofortified variety Pusa Basmati 1509 performed better in zinc loading ability from root to shoot and white rice kernel as compared to the, biofortified variety DR than 45, and soil plus foliar application was better than single source. So this is just, that how much increase was there in the extra because of, that application, or we have not calculated, but here we have been able. Then this is a pictorial view we have given. Here I would like to mention that Pusa Basmati 1509 was better in terms of the zinc concentration loading in white rice kernel as compared to the DRR than 45. Whatever they have claimed DRR than 45, 22.5 milligram per kg of rice, we got only 14, 15 milligram. We did not get a, that white rice kernel more than that 15, 14, 15 milligram per kg of grain. So that means breeders also need to see that they need to work in collaboration with the agronomists to evaluate before releasing of biofortified variety. That paper we have published Journal of Soil Science and Plant Nutrition. And then we have also, estimated some phytic acid concentration. Phytic acid is very important. You know that there is a negative correlation, and if we can increase, you know that zinc concentration, then there is a decrease in the phytic acid. Phytic acid concentration in grain. With increase in the zinc concentration, that means we have taken different, you know that foliar feeding and then soil plus foliar. So that means there is a decrease in the phytic acid. And if we can reduce the phytic acid, that means we can increase the zinc concentration, absorption and uptake in the plant and also human body. So we have, you know that reported in Journal of Food Composition Analysis, where we have shown that soil plus foliar application enhances its biofortification, viability, and productivity in both biofortified and non-biofortified wheat varieties. But it was reverse was the case in that rice. Wheat we got in both the crop, both the biofortified and non-biofortified varieties. The response was there. This is sulfur. I think it is not required. Then what are the benefits of that zinc enriched, you know, that seed and grain? I am coming to my conclusion. So if we get that seed enriched, you know, that with the zinc, it increase the you know that resistance to diseases, decrease the seedling rate, improving the human nutrition, better seed viability and seedling vigor, improving abiotic stress tolerance, and higher yield under zinc deficiency. So that means agronomic biofortification is, you know, leading to increase the productivity by avoiding the insect pest disease attack, giving the more resistance, abiotic stresses, and what is the recognition of our work? Here I would like to mention that international recognition for our work as a, you know, that biofortification work. We have published in 2014 one invited article in Advances in Agronomic Biofortification of Cereal Grains with Iron and Zinc. In 2014, almost you can say 12 years back, we were invited. And for your kind information, young generation, Advances in Agronomy, if you are able to publish, that means you are a well-established soil scientist, agronomist, or natural resource manager, even breeders. They wish to publish. So in 2014, we have published one article we have published in Encyclopedia of Soil Science, where we have, you know, that contributed one article, food crops, zinc and iron biofortification. And in 2024, we have published another article, cereal crops, a valid option for biofortification and development of nutrient-dense food in developing and developed, you know, that countries, specifically in Asia and Africa. So that means developing and develop. That means it is very important. So we have published 2 review articles on agronomic biofortification in Advances in Agronomy. It shows that we have done some work. That is why they are asking to, you know, that invitation they are giving us. And if you publish one article in, you know, that Advances in Agronomy, you need not to pay anything, but you will get $500 US. So that means this is the only journal which those who are paying to the authors, not asking to pay the article, you know, that article publishing charges. So what is the impact of our work on that, you know, that agronomic biofortification or zinc enriched urea, and then particularly specifically using bioinoculant, biofilm, or green manuring, or cropping system based research. We have encouraged the young colleagues and students to work on micronutrient, particularly problem related to zinc nutrition. I have guided almost 25 students so far. 5 students are working under my supervision still, but 2 very recently will submit. 8 students out of that 25 students, 8 students had work exclusively on zinc research. Other scientists in the division, I have motivated elsewhere, got inspired and zinc related problems, and we have also established laboratory zinc, you know, the micronutrient laboratory in our division. We have also shared knowledge and experiences on zinc by delivering some lectures, just like I am delivering today, seminar to students, and also in international conferences, symposia. So far, 5 international zinc symposium has been conducted globally, and I have attended 4. One I attended, which was second in Istanbul, third was in India, Hyderabad, fourth was in Brazil, Sao Paulo, and fifth was in Belgium. And now this year they are going to organize 6th International Economic Congress, because we are celebrating 100 years of essentiality zinc established as an essential plant nutrition. So anybody, if you are interested, you can participate, you can contact me, you can submit your paper. Singapore, it will be conducted in Singapore. Not much money will be required. And our work on zinc has widely been referred by other research around the world, which I think is a good sign. We started urea, then you know that this neem oil coated urea, then sulfur coated urea in the market. What next? I wish that 1% zinc coated urea or 0.5 to 1% zinc and urea must be made available depending on the intensity of the zinc deficiency in our soil or our, that food chain. This is my wish that this should be made available. Future line of research, considering the benefit research on zinc-coated urea, we want that beyond the rice wheat system, this need to be promoted to other cropping system, and more thrust should be given to development of the zinc efficient genotypes, particularly in the areas of soil where the zinc deficiency is there, or severe zinc deficiency is there. And we need a multidisciplinary team involving plant breeders, soil scientists, plant physiologists, agronomists, crop nutritionists, animal nutritionists to work in tandem to tackle the problem to overcome the zinc deficiency from the food chain. So with this, I would like to thank you for your kind attention and giving me this opportunity to share some of my experiences working on zinc nutrition. And you can follow me if you are interested. This is Google, citation, ResearchGate, then ORCID is there, then Web Science of there, Scopus is there, then also IARI detail. So I think thank you very much for giving me this opportunity. I stop with this my lecture. Now questions and answers are invited, or over to you, Dr. Pragati Srivastava.
Thank you so much, sir,
Oh.
for such an insightful presentation. I would request all the participants to put up your question in the chat box, or you can unmute yourself and ask question directly to sir.
Should I remove this presentation or should I keep it?
Sir, keep it. Maybe like participants may have question there as per the slides maybe.
Okay. Okay.
Participants to unmute their self and please ask question one by one to sir.
It shows either I have not told anything, there is no curiosity, or they have understood everything.
Yes, sir. There is one question from Mr. Ajay Sharma. He is praising you for the presentation for such an informative and insightful session. His question is, which countries have successfully implemented zinc biofortification strategies, and what key lessons can be learned from their experience for wider adoption and implementation?
It's a very good question. I must appreciate to the audience, those who have put up this question. There are 2 examples globally where that selenium deficiency in Finland, it was a serious problem, selenium deficiency. People were suffering from that, that winter depression. And they were not knowing what is the cause of that winter depression. People are severely affected. So when then they went for serum, that estimation different nutrient, and then they found that zinc, this selenium is deficient in their serum. And then they analyze this their soil, also the selenium content, and they found that selenium content is very less in their soil. So what they did that selenium enriched fertilizers NPK, and then they applied, and now there is no problem of the selenium deficiency in the Finland. 100%. It is a success story of the agronomic biofortification of selenium through the that agronomic intervention. Another example is the zinc deficiency in Turkey. It's Professor Ismail Çakmak, who was a global, that program leader of the Harvest Plus for agronomic biofortification. So in Turkey, they have also overcome by, that adding the zinc in the NPK or urea. Now there is no deficiency of the zinc in the soil. They have overcome, and also in the human population. These are the two best quoted examples globally where that agronomic intervention has led to the overcome of the selenium deficiency in Finland and zinc deficiency in the Turkey. And even I have seen when I have visited, that Anatolia region of the Turkey, that where they did apply zinc or where they have not applied, it was clear differences were there in the wheat crop. So acute deficiency was there.
So there is one more question from Yugdeep. He's asking, sir, as you have been to China, what is the main difference you found between India and China? Will recommend student to go in foreign for studies like China, and how was your experience in China?
I say again a very good question. I must compliment. When I was trying to go some countries for my postdoc for visiting scientists, I applied several opportunities. At that time, there was no internet. At that time, there was no WhatsApp. At that time, there was no email. There was no mobile phone. So I was just seeing the employment news, and then that I was trying to apply. So whenever I get opportunity, I applied even for that Academic Commonwealth Fellowship UK. I did not get it. Then I tried for the DART Fellowship in Germany. 1 year I got the placement, but that I was not got selected. 1 year I got recommended, but I did not get a placement. So I was really frustrated. So then I applied Chinese government scholarship, which was advertised by the Ministry of Human Resource Development, Government of India. So I applied and I got it. And then when I was going, people were saying, "Where are you going?" I said, wherever I get opportunity, I am going, and let me go. So I went there and I realized that how much difference is there in China and India. At that time in 98, 99, I can say 28 years back. 28 years back, China was almost, that 30 to 40 years ahead than India in all aspects, whether it is agriculture, infrastructure, or there, that any kind, wherever you will go, you will find a difference. Because when I went there, I hail from this NCR National Capital Region. When I went there from this India, the one bridge was being constructed, and when I came again, it was not completed, it was constructed. But when I was in China, where I was living, near to my living place, that within a 3 months, overbridge was constructed and operationalized. That much of efficiency was there in all aspects. Even I met with the Wu Luangwang, who is the hybrid father of hybrid rice in National Hybrid Rice China Center. So that means they are highly dedicated. They work from 8 to 5. No democracy is there. I can say communism is there, but they have China is first for them. One language, one nation. Our country, there are a lot of languages are there, and a lot of problems are there. Lot of that in the name of democracy, in all aspects, we need to learn from the China. And I have seen during my stay one year complete, many that leaders were going and just enjoying and coming back, but they were not implementing. So really, we must learn how to develop ourselves, how to control our population, and how to develop in all aspects. We should not dependent on others. Like still we are, that dependent on others. Agriculture is of course important. They are having a huge demand of that agriculture community. Their productivity is almost just double than us. So they have done excellent job, specifically in agriculture, not only in agriculture, in their own creation of the infrastructure. They created, that road 18 kilometer at that time, 98, 99 in the sea. It was just unimaginable for me. I was not imagining because that I have never seen such type of situation. And I learned the language also Chinese. It was very difficult, but I learned 3 months Chinese language. If in young stage you go in China, it is a really country where people can enjoy, people can make money even because they are very open in all aspects. So at that time they were not so much open. There was no direct flight. Via Hong Kong I went. This was my first flight. After that, I don't know how much time I have board the flight, but this I remember that flight also till today.
So there is one last question from Rahul. He is asking, sir, you have studied the comparison between pigmented rice and white rice varieties on the basis of zinc and iron concentration. Is pigmented rice contain high nutrition value as compared to white rice?
I have studied not that pigmented rice, but I have studied the brown rice and white rice kernel. So brown rice means unpolished rice. White rice means polished rice. So brown rice contain more zinc and iron because most of that alluvial layer remain intact. There is no removal. But when we go for whitening or polishing, that means alluvial layer is removed. And because of that reason, it contains less micronutrient.
Sir, Saida Neher Zehra, she is thanking you for such an amazing session. You have truly explained everything so clearly and inspired us all. Hope to have you again in such sessions and learn more from you in the future.
Thank you one and all for your gracious presence and giving me this opportunity. I appreciate. Thank you. So should I leave now?
Yes, sir. Sir, Dr. Evangini, please conclude the session.
I have a question.
Dr. Evangini, are you there?
Yes, ma'am. Yes, ma'am. Thank you so much, sir, for such an enlightening and informative session on zinc agronomic biofortification for food and nutritional security. Your vast experience, scientific wisdom, and the way you explain the concept with such a clarity have truly made this session highly enriched for all of us. Also, sir, thank you so much for accepting our invitation in such a short notice and blessing this platform with your esteemed presence. And I believe that all the participants greatly benefited from your talk today and gained a deeper understanding of the subject. I would also like to sincerely thank all the participants for their active participation throughout the session. And we hope today's interaction has become the source of inspiration, learning, and motivation for your future journey. With this, we come to end of this session and you all are free to leave this meeting. Thank you.
Thank you one and all. Thank you.